this section will kind of start off looking very similar to what we've already done before. For example, we'll talk about union, and intersection. So a union talks about everything. More specifically, everything that's in one or even both circles. Whereas an intersection is just talking about the crossover, or literally has to be in both. It has to be in both. So when we talk about union, we talk about everything. This one is an example of a union. And the key word that you're looking for those unions is that or word. For an intersection, it has to be in both circles. And the key word that you're looking for an intersection is and. Now, remember, we had a little terminology on this one. A, but not B. So if we're talking about it being in one thing, but not in the other, it could be talking about everything in here, but not in this circle. And disjoint sets are these. So what we're actually talking about is we're talking about actually not that, non/mutually exclusive events. In other words, talk about the addition of probabilities. We'll talk about what non and mutually exclusive events are. This is the formula that we'll use for non-mutually exclusive events. So and all that really means is just that there's some overlap. Because probability, that's what that big P is going to stand for. It stands for probability. Probability of A union with B just takes the probability of something in A happening. So we talk about here. Probability of A happening, adding the probability of B happening, and subtracting the intersection. Because if you talk about A and B, you have to subtract one of these intersections because otherwise it would just be counted twice. So let's look at the integers from 1 to 15 are written on identical slips of paper and placed in the hat. If one of the slips of the paper is drawn from the hat, find the probability that is an odd number or an integer larger than 8. So let's start with a Venn diagram because it's something that we're familiar with. Two nice little circles. So let's identify these two things. We have odd numbers and integers larger than 8. So let's make this first circle odd numbers. And let's make this one greater than 8. So let's look at the numbers. Integers from 1 to 15. 1 definitely is odd, but it's not larger than 8. 2, not even considered. 3, yep, that's odd. 4, not larger than 8, not odd. 5, 6 would not be considered. 7 is odd. 8. Now 8 is not odd, so 8 would just be there. 9, well 9 is both. It's both odd and it's greater than 8. So 9 would be there. 10 would be there. 11 in our intersection. 12, oh, larger than 8, sorry. Let me fix that up. Larger than 8 means it's not greater than or equal to, it's just larger than 8. So we'll have to be very careful. 8 would actually be on the outside. I apologize. Just getting a little bit too excited here. 13 would be an intersection. 14, and 15. So if you look at all the numbers, let's see how this formula actually works. What would be the probability of A union with B? Now actually, let's change this. Let's change what our A's and B's are. Let's say that A is, what about it being odd? Whereas B is talking about something that would be greater than 8. So if we take the probability of something being odd, we add it to the probability of numbers that are greater than 8, and subtract the probability of it being odd and, which is what that intersection is. Remember that little symbol there talks about and. Greater than 8, we'll find everything out perfectly. Now, obviously, we've done our Venn diagram, which would work out nicely. We could literally just do it as is, but at the same time, I'm showing the formula to make things more obvious. So the first question is, how many numbers from 1 to 15 are odd? Well, if you just count it up, 1, 3, 5, 7, 9, 11, 13, 15, it would be 8. And what the probability is, it's 8 out of 15, because there are 15 total numbers from 1 to 15. How about how many numbers are greater than 8? Well, you have 9, 10, 11, 12, 13, 14, 15, which works out as 7 numbers out of 8. Then we have to subtract how many numbers are both odd and greater than 8. Well, we can read it right from our Venn diagram. It's 9, 11, 13, and 15. 4 out of 15. So, oh, sorry. Getting way too many errors today. Just having way too much fun. 7 out of 15. I'm not sure why I wrote 7 out of 8. I am extremely sorry. But either way, since all of our denominators are the same now, 8 plus 7 is 15. Subtract 4 is 11 out of 15. That would be the probability of a number being odd or greater than 8. And absolutely, we can count that up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the Venn diagram has just helped us. The formula has helped to explain what these different parts are. So I'm just going to rewrite that formula right down. Probability of A or B happening. Probability of A happening plus the probability of B happening, subtracting the probability of A and B happening. Now again, this is a non-mutually exclusive. There is a formula for actual mutually exclusive, which looks almost the exact same thing. Mutually exclusive are these. This is an example of a mutually exclusive mutually exclusive, meaning they're completely separate from each other. Non-mutually exclusive is anything that there's an actual overlap. So the way that the formula actually changes when you have something completely mutually exclusive is you just take out that intersection part. There is no overlap. There's no intersection. Because really, what you're doing is you'd be subtracting 0. Well, if you subtract 0 from anything, you're not going to change it. So that's the entire difference. Anyways, let's keep on rocking. A red and white die are tossed. Find the probability that a die shows 3 or the sum of the dice is 8. So again, that or indicates we're looking for that union. So just like the last section, I'm gonna make a nice table here. Now I don't have really a white marker, but I do have black. So we'll substitute white for black. Three, 4, 5, 6. Once again, I'm just going to pause. So the question is saying, we want to know what's the probability of having a die showing 3 or the sum of the dice being 8. So for a die to show a 3, well, that's talking about all of these options, as well as all of these options. Because the red die could be showing a 3, or the white die could be showing a 3. Three union with, I'll just go shorthand with 8. 3 plus probability of the 8s, subtracting probability of 3 and 8. Now, there is a little bit of a sticky point to this one. I just want to try and condense our lessons as much as possible. This fact of it being a 3, we have to be careful with this one because we don't want to count this option twice. We don't want to count that, oh, there's a 6 here, or like both of them showing a 3. It's just, we just need to know that a die shows 3. Doesn't really mean that they both can't show 3. You kind of have to read the question. But in total, how many times are there actual 3 showing? Well, there's 6 there. There's 6 there, but we're not going to write 12 because we're not going to duplicate this intersection here. So it would only be 11 out of 36. And then if we go and talk about how many times does a sum of 8 show up, well, that's all 5 of these options. So 5 out of 36. Now what we need to do is we need to subtract how many times does a die show a 3 and a sum of 8 happens. Well, that's that one and that one. So we have to subtract the overlap, the intersection of these options. So we subtract that 2. Finish her off. 11 plus 5 is 16. Subtract 2 is 14. Of course, reduce where possible. If you need to go to a decimal, no, 0.38 repeated. Or if you go to the percentage, 38.8%. 8 repeated. Of course, if I say just to the nearest tenth, I would expect that you go 38.9. I'm just going to cheat slightly. I just copy and paste to the table so it would work. I just wanted to make it a brand new table so for our new question. So our question now says, what's the probability of a red die showing a number greater than 4 or the white die showing a number less than or equal to 2? So what would be the red die showing greater than 4 unioned with the white showing something that is less than or equal to 2? So greater than 4 plus the probability of it being less than or equal to 2. Subtracting how many times do we get it greater than 4 and less than or equal to 2? So let's take a look at it. So the red die showing a number greater than 4. Well, greater than 4, can't be equal to, that'd be all 12 of these options. 12 out of 36. If we're talking about how many times does the white die show something that's less than or equal to 2, less than or equal to 2, we all 12 of these options. Okay, same number, just coincidence. And then what we need to do is we need to subtract how many times is there an overlap, an intersection. Well, that's those 4 there. I'm happy that this one actually worked out nicely with colors. Anyways, 20 out of 36 reduced to be what? 5 out of 9? Divide by 4, divide by 4. Yeah, should work. This one I can do in my head. Yeah, equals 55.5%. 5 out of 9 would be the better number. That allows us to do what we need to. Okay. Last example. Using a standard deck of playing cards, find the probability that a red card is drawn or a 2 is drawn. So let's do this without anything. We'll just talk through it. So we need to know what's the probability of having a red card, union, that's what the or is standing for, a 2. So what's the probability of a red card happening? What's the probability of a 2 happening? And what's the probability of having a red and it being 2? So in total, red cards, there would be 26. Diamonds and hearts altogether is 26, 13 and 13. Whereas the total number of 2s, well, there's 4. There are 4 2s in a deck. Subtract how many of those red cards are also 2s. Well, you have the 2 of diamonds and 2 of hearts. There's only 2 of them. So that all works out as 28 out of 52. Once again, I can divide by 4, so I get 7 out of 13. Let's leave it as a fraction, and you can have some fun.